So the law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. And we know that side AB in triangle ABC equals to A units in its length. Side AC in this triangle equals to B units in its length. Side BC equals to C units in its length. And the angle between side AB and side AC is alpha. Then according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. So here we will add 2 times AB cosine alpha to this equation and we'll subtract C squared, and we'll get that 2 times AB cosine alpha equals to A squared plus B squared minus C squared. We divide this equation by 2 times AB and we get that cosine alpha equals to A squared plus B squared minus C squared over 2AB. Okay, so we can implement the law of cosines in triangle ECB. Now a triangle, so according to the law of cosines, here A is EB, B is EC, and C is BC, that is X. So here we will get that according to the law of cosines, in triangle EBC, we get that cosine alpha equals to A squared is EB squared plus B squared is EC squared minus C squared. C is BC, so minus C squared is BC minus BC squared over 2 times EB times EC here EB equals to 5 plus 5, this is 10. EB equals to 10 and EC equals to 4 plus 6, that is also 10. So EC is also equals to 10. And we have already found out that cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5 and we get that 4 over 5 equals to EB squared. EB equals to 10, so EB squared is 10 squared, that is 100, plus EC squared. EC equals to 10, so EC squared is also 100 minus two times minus C squared, that is actually minus BC squared. It's actually minus x squared over 2 times EB, that is 10, times EC, that is also 10. So here in the numerator we have 2 times 10 times 10 is 200. This is what we have in the denominator. 10 times 10 times 2 is 200. And in the numerator we have 100 plus 100 is 200 minus x squared, that is equal to 4 over 5. Here we will multiply this equation by 200 and we get that 200 times 4 over 5 equals to 200 minus x squared. 200 over 5 is 40, and 40 times 40 is 160, and it is equal to 200 minus x squared. So here we will add x squared to this equation, and we get that x squared plus 160 equals to 200. Here we subtract 160 from this equation and we get that x squared equals to 200 minus 160 is 40. X squared equals to 40, so we take a root out of this equation and we get that x equals to the square root of 40. 40 is 4 times 10, so we substitute 40 by 4 times 10. The square root of 4 is 2. So in conclusion, we found out that x equals to 2 times square root of 10 units. So in terms of numbers, it is equal to 6.32 units. Okay. I will repeat again. X equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Okay, x here equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. We finished with the first method. In the next step I will present to you how to find out the length of this line segment BC that is equal to x according to the second method. In the second method, we will do another construction. From point E, we will draw a straight line on DC in such a way that the straight line that we will draw will be perpendicular to BC. I repeat again, we drew the straight line AE in such a way that AE is parallel to BC. I write it down that AE is parallel to BC according to our construction. In the next step, from point E, we'll draw a straight line on BC in such a way that the straight line will be parallel to AB. Here we define The touching point of the straight line from point E and BC is point F. So we drew the straight line EF in such a way that EF is parallel to AB. Again, EF is parallel to AB according to our construction. Actually, quadrilateral AEBF is a parallelogram because it has two couples of sides that are parallel to each other. The first couple of sides that are parallel is AE is parallel to BF, and also AB is parallel to the second couple is AB is parallel to EF. Therefore, can I know that quadrilateral AEBF is a parallelogram. Okay? And we also have rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I'll read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here we know that AB is parallel to EF according to our construction. AB is parallel to EF. AB is parallel to EF according to our construction. We know that AB is parallel to EF according to our construction. Therefore, according to rule number 3, we conclude from it that those two corresponding angles that are located between the parallel lines A, B, and EF will be equal to each other. That is to say, angle ABC equals to angle EFC. Angle ABC equals to angle EFC. According to rule number 3, that those two corresponding angles that are located between the parallel lines A, B, and EF are equal to each other. Okay? But it is given us in the question that angle ABC equals to theta. Angle ABC equals to theta. So from this equation, theta equals to ABC equals to EFC, we will derive that angle EFC is also equal to theta. So this angle is also equal to theta. Likewise, according to rule number 3, because of the fact that AE is parallel to BC, let's see here. AE is parallel to BC according to our construction. Okay, we drew the straight line AE in such a way that it will be parallel to BC. So AE equals to BC. AE is parallel to BC. AE is parallel to BC. AE is parallel to BC according to our construction. Here, AB is parallel to BC according to our construction, and FE is parallel to AB according to our construction. Okay, so A is parallel to BC according to our construction. Therefore, from rule number 3, we conclude that those two angles that are located between the parallel lines A and BC will be equal to each other. That is to say, angle DEA is equal to this angle that is actually angle DCB. According to rule number 3, of course, again, those two angles are located between the parallel lines AE and BC, therefore they are equal to each other according to rule number 3, that is to say, angle DAE equals to angle DCB according to rule number 3. Okay, but angle DCB equals to theta according to what is given as the question. Here, we know that angle DAE equals to angle DCB according to rule number 3, of course, but it is given as in the question that angle DCB equals to theta. So I can write here that angle DCB equals to theta according to what is given as the question, and from this equation angle DA equals to angle DCB equals to theta, we will derive that angle DEA is also equal to theta. Very simple. So this angle is also equals to theta. Okay. So here I present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. The opposite sides of a parallelogram are equal to each other. I'll read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we focus on parallelogram AEBF, in P is abbreviation for parallelogram AEBF, according to rule number 4, in parallelogram AEBF, we will get that AB equals to EF. AB equals to EF, very simple. According to rule number 4, AB must be equal to EF, because those sides are two opposite sides and they must be equal to each other according to rule number 4. Okay? But it is given as the question that AB equals to 5 units. So we can write here that AB equals to 5 units. And from this equation 5 equals to EB equals to EF, we will derive that EF is also equals to 5 units. Okay, so EF is also equals to 5 units. If we focus on triangle EFC. In triangle EFC we have two equal angles. In triangle EFC we know that angle EFC is equal to angle ECF, and both angles are equal to theta, therefore they are equal to each other, of course. And from rule number 1, in front of equal angles there are equal sides. We will conclude that EF is equal to EC. Okay, therefore, according to rule number 1, EF must be equal to EC. EF must be equal to EC because of the fact that in front of those two equal angles there are two equal sides. That is to say, EF equals to EC according to rule number 1. Okay, but we have already found out that EC equals to 5 units. Here, you can write down that EC equals to 5 units according to what we have already found out, that from this equation 5 equals to EC equals to 5 equals to EF equals to EC, we will derive that EC is also equal to 5 units. EC is also equal to 5 units. And here we have what is the length of the small line segment DE. It is very easy to see from the drawing that DE equals to DC minus EC. DC minus EC equals to DE. I repeat again, DE equals to DC minus EC. So DE equals to DC, that is 6 units, minus EC, that is 5 units. In conclusion, we found out that DE equals to 1 unit. Here, DE equals to 1 unit. Now we can find out the hypotenuse of the right small triangle ADE. In this right small triangle, according to the Pythagoras theorem, small right green triangle, triangle ADE, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AE, so AE squared equals to AD squared plus ED squared. So AE squared equals to AD squared. AD equals to 3 units according to what is given as the question. So AD squared is 3 squared, that is 9, plus ED squared. ED equals to 1, so ED squared is 1 squared, that is 1. So in conclusion, we found out that AE squared equals to 9 plus 1, that is 10. Here we'll take a root out of this equation and we get that AE equals to square root of 10 units. So AE equals to square root of 2 units. And according to rule number 4, the opposite sides of a parallelogram are equal to each other. So in parallelogram AEBF, we will get that AE must be equal to BF according to rule number 4. AE must be equal to BF according to rule number 4. But we have already found out, we just right now found out that A equals to square root of 10 units. So I can write here that A equals to square root of 10 units, and from this equation, square root of 2 units equals to A equals to BF, we will derive that BF is also equals to square root of 10 units. Okay? BF is also equals to square root of 10 units. So here, from the drawing, it is very easy to see that BC minus BF equals to FC again. BC minus BF equals to FC. Okay, write it down. I repeat again, from the drawing, it is very easy to see that FC equals to BC minus BF. So FC equals to BC, that is actually X, according to what is given as the question, minus BF. We just right now found out that BF equals to square root of 10. So in conclusion, we found out that FC equals to X minus square root of 10 units. So I write here that FC equals to here FC equals to X minus square root of 10 units. Okay? So in the next step we draw perpendicular from point E to the base of the isosceles triangle, triangle EFC. First of all, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units, and the base of the isosceles triangle is FC. So from point E we draw perpendicular to the base FC. So actually here the perpendicular from point E on FC, it is actually the height to the base FC. I repeat again, the perpendicular from point E on FC, it is actually the height from point E to the base FC. We define the touching point of the perpendicular from point E on FC as M. Again, line segment EM is perpendicular to FC, that is to say, line segment EM is the height to the base FC of the isosceles triangle EFC. Okay, so I write it down. EM is the height to the base of the isosceles triangle EFC. So we have also rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. I'll write it down. The height to the base in an isosceles triangle bisect the base. I'll repeat again on rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So I'll repeat again that triangle EFC is an isosceles triangle because of the fact that EF equals to EC. I'll write it down here. EF equals to EC equals to 5 units. From that we will derive that triangle EFC is an isosceles triangle and the base of the isosceles triangle is FC. FC is the base of the isosceles triangle, and here EM is the height to the base, as I already explained. EM is the height to the base FC of the isosceles triangle EFC. According to rule number 5, the height EM to the base FC bisect the base. That is to say, the height EM divides the base FC into 2 equal parts. That is to say, according to rule number 5, FC equals to MC. FC equals to MC. And so, for that reason, each of them, they are equal to half of the length of FC. That is to say, FC over 2 equals to FM equals to MC. So here MC equals to FC over 2. FC is x minus square root of 10. and FC over 2 is x minus square root of 10 over 2. So we actually found out that MC equals to x minus square root of 10 over 2. Again, according to rule number 5, in isosceles triangle EFC, we know that FC is the base, so the height EM to the base FC bisects the base FC. That is to say, it divides to two equal parts. That is to say, FM equals to MC, and it is actually also equals to FC over 2. Why? Because FC over 2, it must be equal to FM plus MC. Because FM plus MC equals to FC from one side. But here, I'll write it down. We know that FM plus MC equals to FC from one side, but for the other side, FM equals to MC. So if we define FM as x, then FC will be equal to x plus x, because MC is also x. So FC equals to 2x, and here, if we divide this equation by 2, we'll get that x equals to FC over 2. X equals to XC over 2. That is to say, we defined x as FM. So x actually, so FM equals to MC equals to also 2x. According to our definition, x equals to FM. And we found out that x equals to FC over 2. So here, x equals to also FC over 2. So in conclusion, we found out that FC over 2 equals to FM equals to MC. Okay? So here, in the next step, we will prove that triangle ADE is similar to triangle EMC. So why those two right triangles are similar to each other? I'll write it down. Triangle the right triangle AED is similar to the right triangle EFC. So why those two right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees. So angle ADE is equal to this angle, this is actually angle EMC. And both angles are equal to 90 degrees. In addition, those two angles are equal, they are both equal to theta, therefore they are equal to each other. So angle DEA is equal to this angle, this is actually angle ECF, and they are both equal to theta. And finally, in triangle ADE, this angle equals to 90 degrees, this angle equals to theta. So this angle must be equal to 90 degrees minus theta. Likewise, in the right green triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be also equal to 90 degrees minus theta. So we found out that those two angles are also equal to each other. So angle DAE equals to angle MEC, and both those angles are equal to 90 degrees minus theta. So we prove that all the three angles of triangle ADE can go into all three angles of triangle EDC. Why? Those two angles are both equal to theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Therefore, triangle ADE, the right green triangle ADE, is similar to the right green triangle EMC, according to angle similarity rule. And from the fact that the two green right triangles are similar to each other, we will derive that AE over EC is equal to DE over MC. I'll repeat again, from the fact that triangle AED is similar to triangle EMC, we will derive that AE over EC equals to DE over MC. Here, AE equals to square root of 10 units, so we substitute AE by square root of 10 units over EC. EC equals to 5, so we substitute EC by 5, and it is equal to DE. DE equals to 1, so we substitute DE by 1 over MC. Here MC, we already found out that MC equals to x minus square root of 10 over 2, so we substitute MC by x minus square root of 10 over 2. Okay? So here we will move to the numerator and x minus square root of 10 to the denominator of this side of equation number 2, and we get that according to equation number 2, square root of 10 over 5 equals to x minus square root of 10 equals to 2 over x minus square root of 10. Here we cross multiply this equation number 2, and we'll get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. But 10 is also equals to square root of 10 times square root of 10. So we divide this equation by square root of 10, and we get that according to equation number 2, square root of 10 over square root of 10 is 1, so we left only here with x minus square root of 10. And there square root of 10 times square root of 10 over square root of 10 is square root of 10. So here we will add square root of 10 to this equation number 2, and we get that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, I repeat again, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finish with the second method. In the next step, I will summarize the lecture. Okay? We'll start with the first method. I'll repeat on the question that we have here. Quadrilateral ABCD. You know that side AB equals to 5 units, side AD equals to 3, D equals to 6. Angle ABC equals to angle DEC equals to theta. Angle ADC equals to 90 degrees. And we want to find out the length of side BC that is actually equals to x. So in the first method, we did a construction. We extended side BA and side CD by a straight line until they intersect with each other at point E. Point E is the intersection point of those two sides. So here we created a triangle EBC that has two angles that are equal to each other. Those two angles are equal to each other, they are both equal to theta. And we have rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So we will implement rule number 1 in triangle ABC. We have here two equal angles, and according to rule number 1, in front of those two equal angles, there are equal sides. That is to say, side EB must be equal to side EC according to rule number 1. EB must be equal to EC according to rule number 1, but EB equals to 5 plus A. EC equals to 6 plus AD. Here we subtracted 5 from this equation and found out that AE equals to 1 plus AD. We defined ED as A. So we substituted ED by A and we got that A equals to 1 plus A. So here ED equals to A according to our definition, and A equals to 1 plus A. Okay? A equals to 1 plus A. Okay? According to this equation, A equals to 1 plus A. Oh, okay? So here A equals to 1 plus A. Then here CD is one side of quadrilateral ABCD. Therefore, it must be a straight line. And then so because of the fact that CD is one side of quadrilateral ABCD, it must be a straight line. And then when we extended the straight line CD by straight line, the result, that is CE, must be also a straight line. So in conclusion, we can write down that CE is a straight line. Okay, CE is a straight line. And we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So according to rule number 2, if we know that EC is a straight line, so if you focus on this side of the straight line CE at point D, according to rule number 2, the sum of the angles on this side of CE at point D must be equal to 180 degrees according to rule number 2. So which angles we have at point D on this side of the straight line CE? We have here 90 degrees and we have angle EDA. So according to rule number 2, 90 degrees plus angle EDA must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle here, angle EDA, equals to 90 degrees. Therefore, triangle EDA is a right triangle. Okay? So we can implement the Pythagoras theorem on the right small triangle EDA. the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE square equals to AD square plus ED square. According to the Pythagoras theorem, in the right small triangle EDA, we get that AE square equals to AD square plus ED square. AE square, AE equals to 1 plus A, so A square is 1 plus A square, and it is equal to AD square. AD is A, so AD square is A square plus ED square plus AD square plus AD square. AD is 3, so AD square is 3 squared, that is 9. So in conclusion, according to equation number 1, we found out that 1 plus A square equals to A square plus 9. We open the brackets on this side of equation number 1, and we found out that according to equation number 1, 1 plus A square equals to 1 plus A square plus 2A, and it is equals to A square plus 9 according to equation number 1. We have A square on both sides of the equation, so A square will get cancelled, and we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation and found out that 1 minus 1 is 0, so here we have 2A, that is equal to 9 minus 1, that is 8. So in conclusion, found out that according to equation number 1, 2A equals to 8. We divided this equation number 1 by 2, and we got that 2A over 2 is A, so, and 8 over 2 is 4. So in conclusion, we found out that A equals to 4 units. So here A equals to 4 units, and here A equals to 1 plus 8, that is to say it is equal to 1 plus 4, that is 5 units. Then we implemented, I presented to you the law of cosines, and we implemented the law of cosines in this triangle ABC. What is the law of cosines? The law of cosines is valid in any triangle. If we have a triangle ABC, this triangle that would be any triangle, we know that side AB equals to A units in its length, side AC equals to B units in its length, side BC equals to C units in its length, and the angle between side AB and side AC equals to alpha. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine alpha. Here we added 2 times AB cosine alpha to this equation, and we also subtracted C square here. So we got that 2 times AB cosine alpha equals to A square plus B square minus C square. We divided this equation by 2AB, and we found out that cosine alpha equals to A square plus B square minus C square over 2AB. Then, as I already told you, we can implement this rule, the law of cosines, in triangle ECB. Actually, first of all, we defined angle BEC as alpha. Here, in the small right triangle AED, cosine alpha equals to ED over AE. Okay? In the small right triangle AED, this right triangle, cosine alpha equals to ED over AE. Cosine alpha equals to ED over AE in the right small triangle AEDE. ED equals to 4, AE equals to 5, ED equals to 4, AE equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. Then, in the right triangle EBC, we implemented the law of cosines. Okay, here, cosine alpha equals to EB square plus EC square minus BC square over 2 times EB times EC. Again, cosine alpha equals to EB square plus EC square minus BC square minus 2 times AB times BC. EB equals to 5 plus 5, that is 10, and EC is equals to 4 plus 6, that is also equals to 10. So, in conclusion, EB equals to EC equals to 10 units. We have already found out that cosine alpha equals to 4 over 5, so we can substitute cosine alpha by 4 over 5. So here 4 over 5 equals to EB squared. EB is 10, so EB squared is 10 squared plus EC squared. EC is 10, so EC squared is also 10 squared, that is 100. Minus BC. BC equals to x, so BC squared is x squared. So in conclusion, we found out that here 4 over 5 equals to 100 plus 100, that is 200, minus x squared over 2 times 10 is 200. So in conclusion, we found out that 4 over 5 equals to 200 minus x squared over 200. We multiply this equation by 200, and we got that 200 times 4 over 5 equals to 200 minus x squared. 200 over 5 is 40, and 40 times 4 is 160. So in conclusion, we found out that 160 equals to 200 minus x squared. We added to this equation x squared, and we got that x squared plus 160 equals to 200. We subtracted 160 from this equation, and we found out that x squared equals to 200 minus 160 is 40. So we found out that x squared equals to 40. We took out of this equation and found out that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6 over 6.32 units. I repeat again, x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method, then I presented to you how to find out the length of side BC that is equal to x according to the second method. In the second method, we did another construction. From point A, we draw a straight line on DC in such a way that AE will be parallel to BC. So AE is parallel to BC according to our construction, and from point E we draw a straight line on BC in such a way that EF will be parallel to AB. Again, EF is parallel to AB also according to our construction. We created here parallelogram. Here AEBF is a parallelogram because two couple of its sides are parallel to each other. AB is parallel to EF, and AE is also parallel to BF, and this is exactly the definition of a parallelogram. Okay, so then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here we know that AB is parallel to EF according to our construction. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other. Okay, according to the fact that AB is parallel to EF, we will get that angle BAC must be equal to angle EFC, because those two angles are parallel angles, and parallel angles that are located between because of the fact that those two angles are corresponding angles, and corresponding angles angles that are located between parallel lines are equal to each other, according to rule number 3. Therefore, angle BAC equals to angle FEC. But angle BAC, this angle equals to angle theta. So those two angles are equal to each other. But this angle ABC equals to theta, according to what is given as the question. Angle ABC equals to theta, so from this equation, theta equals to ABC equals to FEC, we will derive that angle EFC is also equals to theta. So this angle is also equals to theta. Okay? Likewise, according to our construction, AE is parallel to BC. According to our construction, AE is parallel to BC. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AE and BC will be equal to each other. Okay? Therefore, angle DAE will be equal to angle BCD according to rule number 3. But here, angle BCD equals to theta according to what is given as the question. So we can write here that angle BCD equals to theta, and from this equation, angle DAE equals to BCD equals to theta, we will derive that angle DEA is also equals to theta. So this angle DEA, also equals to theta. Okay? So in triangle, then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. Okay? So if we relate to the parallelogram AEBF, according to rule number 4, its opposite sides are equal to each other. That is to say, AB equals to BF, AB equals to EF, AB equals to EF, according to rule number 4, AB equals to EF. But it is given as the equation that AB equals to 5. So can I think that AB equals to 5? And from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5. Okay, EF is also equals to 5. So in triangle EFC, we know that those two angles are equal to theta. Okay, in triangle EFC, we know that angle EFC equals to angle ECF equals to theta. And we have rule number 1 that in front of equal angles in the triangle there are equal sides. So according to rule number 1, because of the fact that those two angles are equal to each other, EF also must be equal to EC in triangle EFC. EF must be equal to EC, but we have already found out that EF equals to 5 units. Here we can write down that EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. Here EC equals to 5 units. So what is the value of line segment DE? DE equals to DC minus EC. DE equals to DC minus EC. DC equals to 6, EC equals to 5. So in conclusion, we found out that DE equals to 1 unit. Now, in the right triangle ADE, we have two sides. Therefore, by implementing the Pythagoras theorem in this right triangle, we'll find out the hypotenuse AE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus AD square. So AE square equals to AD square. AD is 3, so AD square is 3 squared, that is 9. Plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So in conclusion, we found out that in the right triangle ADE, according to the Pythagoras theorem, A square equals to 9 plus 1. 9 plus 1 is 10. So A square equals to 10. we took out of this equation and found out that A equals to square root of 10 units. Here A equals to square root of 10 units, so in parallelogram AEBF, the opposite sides are equal to each other, that is to say AE equals to BF. According to rule number 4, AE equals to BF. But we already found out that A equals to square root of 10 units, so from this equation, square root of 10 units equals to square root of 10 equals to A equals to BF. We will derive that BF is also equals to square root of 10 units. BF equals to square root of 10 units. So here, what is the value of FC? From the drawing you can see that BC minus BF equals to FC. Okay, here BC FC equals to BC minus EB. It is very easy to see from the drawing that BC minus BF equals to FC. Again, BC minus BF equals to FC. So if FC equals to BC minus BF, BC equals to X, according to what is given as the question, BF equals to square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. Here, FC equals to X minus square root of 10 units. Okay? Then, triangle FEC is an isosceles triangle because of the fact that AE equals to EC equals to 5 units. And therefore, FC is the base of the isosceles triangle, triangle FEC, and the I to the base is AM. The I to the base is EM. EM is perpendicular to the base FC. Therefore, it is the I to the base. Okay. Okay. So then I presented to you rule number 5. According to rule number 5, the I to the base in an isosceles triangle bisects the base. Okay. So here, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5. And as I already told you, FC is the base of the isosceles triangle, triangle FEC. Okay? So according to rule number 5, the ITM to the base FC bisects the base FC. That is to say, it divides the base FC to 2 equal parts. That is to say, FM equals to FC. Okay? FM equals to FC, and it also divides the base into 2 equal parts. That is to say, if the base is FC, it divides it to 2 equal parts. So each part must be equal to FC over 2. That is to say, MC equals to FC equals to FC over 2. Why? Because each part is half. It divides this to 2 halves. So this will be equal to FC over 2, and this will be also equal to FC over 2. And FC over 2 plus FC over 2 is FC. So in conclusion, FC over 2 equals to FC equals to MC. Okay? So here, MC equals to FC, that is X minus square root of 10 over 2. Okay? So here I show to you that FC equals to FM plus MC. So FC over 2 equals to X equals to FM equals to FC. FM equals to MC according to rule number 5. So if we define X as FM, then we get that FC equals to FM, that is X, plus MC, that is also X, so FC equals to 2X, that is to say X equals to FC over 2. So X equals to Fm, that is equal to Fc over 2. So Fm equals to Fc over 2, and MC is also equals to Fc over 2. So in conclusion, found out that Fc over 2 equals to Fm equals to MC. Then we proved that those two right triangles are similar to each other. Why those two right triangles are similar to each other? First of all, those two angles are equal to each other. They are both equal to 90 degrees, therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. And here, in the right triangle ADE, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. Likewise here, this angle equals to 90 degrees, this angle equals to theta, so this angle also must be equal to 90 degrees minus theta. So in conclusion, found out that those two angles they are equal to each other because they are both equal to 90 degrees minus theta. So all the angles of triangle ADE can go into all the angles of triangle MEC, therefore those two triangles are similar to each other and goes into angle similarity rule. Okay, triangle ADE is similar to triangle EMD according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. Again, AE over EC equals to DE over MC. Okay, AE over EC equals to DE over MC. A equals to square root of 10 units, EC equals to 5, D equals to 1, and MC equals to x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator, and we got that square root of 10 over 5 equals to 2 over x minus square root of 10. We cross multiply this equation number 2, and we got that square root of 10 times x minus square root of 10 equals to 10, but 10 is square root of 10 times square root of 10. So we divided by square root of 10 this equation number 2, and we got here that square root of 10 over square root of 10 is 1, so we left only here with x minus square root of 10, and here square root of 10 times square root of 10 over square root of 10 is square root of 10. Here we added square root of 10 to this equation number 2, and we found out that x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Okay? Thank you very much.